Okay, so this is y equals x plus 1 squared. Now, what does the 1/2 do? Okay, notice it's a positive 1/2, so I don't flip it around the bottom. But what does it do? It moves it up a half. No, it doesn't move it up a half.
Stretches it.
Stretches it, not exactly. It shrinks it. It makes it short and fat. So in other words, instead of going up 1, it only goes up a half. Instead of going up 1, it only goes up a half. Instead of going up 4, it only goes up 2. You with me? Okay, let's do it in a different color. So now we go instead of going 3, 9, we go 3, 4 1/2. Okay? Looks something like that. So this black one is y equals 1/2 x plus 1 squared. And then what does the minus 3 do? Doesn't flip it.
It goes to the left. It goes, yeah. It goes right 3.
Doesn't go to the right.
It goes to the left.
Doesn't go to the left 3.
Flips over.
Somebody said it.
Yeah.
Down. Come on, folks.
That's where the plus that goes.
The last number on the right, it just h of x, the y number, gets subtracted 3. It goes down. The whole graph just drops 3 units. Okay? So this goes down 1, 2, 3. This goes down 1, 2, 3. So the graph now looks like, so this was up 2, gets down 3, so it gets to here. So the graph looks like this. Okay, so you're on the test, you're going to get a question very much like this, problem 17. I'm going to word it a little differently. I'm going to say, for this particular function, and it's going to look like, it's going to be in this format here. It's going to be in the format. The numbers are not going to be the same exactly, but you have to know that this x plus 1 or x minus 5 moves it left, right. This thing, stretches it up or makes it short and fat, or if it's negative, it flips it around, and then this thing drops it down 3 or raises it 5, whatever. Okay, so what I'm going to ask you is I'm going to say, what is the vertex? And you have to tell me the vertex, literally as an ordered pair. What's the vertex?
1
You can look at the graph and you can see 1,
1 negative.
1 negative 3. Now, you know what? You can come up with the vertex.
Negative 1.
Negative 1, negative 3.
Did I make a mistake?
Negative
1, negative
3.
Okay, who caught it? I think I saw. Who caught it first? I think
Somebody
I
else yelled
I think
it.
I
She got it first.
She yelled it.
-1, -3. Oh, I hate making mistakes.
We love it.
H.
We like you like it.
J.
Or J, sorry. J. Okay. So, -1, -3. Now, folks. Let me finish. You taking my picture?
I'm making a movie. I have to record this because I'm so confused.
You're really confused?
Very much. I just have a quick question, and maybe it will help me.
Okay, go ahead. What?
I don't understand even, where do you just start? When you just, the first step I'm going to do is plug 0 in x and then say it moves to the left?
Okay, the first thing you're going to do is you're going to start here. You're going to start y equal x squared.
Uh-huh.
Okay? Just like if you remember, that's when we started when I did the very first problem.
Sure.
Okay? Then this here tells you whether you go left or right, how many units. But it's a little confusing because plus means you go to the left. Minus means you go to the right. And the number tells you how far. So a plus 1 says we go to the left 1 unit, which brought us here, see?
From 0, 0. Okay.
From 0,
That's
0.
where I was
The
confused.
whole graph is getting pushed to the left 1 unit.
Okay.
Then the coefficient in front is what stretches or shrinks. And if it's a negative, it flips. And then finally, this last number takes the whole graph and either lifts it up or races it down.
Pushes it.
Pushes it down. Question?
Yeah. Why do we need to break it down like y1, y3? And instead of breaking it down, why don't we try to graph it as it is? Like,
Okay, you got it. That's a good point. And in fact, that's a good point. Okay. And in fact, I'm gonna get. You asked about a shortcut. I'm going to give you sort of the shortcut. First of all, we didn't have to go to all this trouble to get the vertex.
Why do you take this, David?
I put it because I felt like it. So this, you better write this down. It's in your book, folks. This is in your book. But this is very important right here. I'd write that down if I were you. When you have an equation in this crazy form, the vertex is HK.
right.
Now be careful with the minus sign. Okay? This is not a minus sign, it's a plus. Putting it into that form, this thing should become x minus a negative 1. You with me? So be careful with the plus minus bit. This has to be a minus sign. If it's a plus, you better change the sign of the constant. Now, HK is the vertex. In this case, negative 1, negative 3. This is your K. Negative 1, negative 3 is your vertex. Okay? Once you have your vertex, you're about halfway or more to doing the graph. Okay? The axis of symmetry. I'm going to ask you for the equation of the axis of symmetry. Okay, the equation. The equation of the axis of symmetry. The axis of symmetry always goes through the vertex. It has the equation x equals, you tell me, x equals what?
2.
1. Oh,
It is one.
Negative
One.
one.
Negative 1.
Negative 1. The x-coordinate of the vertex is going to tell you what the axis is. The axis of symmetry is x equals negative 1. And I'm going to ask you for the equation of the axis of symmetry. The equation. If you give me negative 1, I'll probably take a point off. The equation is x equals. Okay? The equation is, the axis of symmetry has equation, x equals h. In this case, h was negative 1. And the max or minimum is always k. In this case, minus 3. The min in this case is minus 3, right? It goes down to negative 3. That's the lowest point. The minimum value. The minimum value is always going to be k. Now, he raised a point. Why can't we, can we do it more simply? Do you have a question? Or?
Yeah, can we write that as h of negative 3 equals negative 1?
I think you mean h.
Axis.
Yeah, I think you mean h of negative 1 equals negative 3, don't you? I think what you mean is h
Yeah.
of negative 1 equals negative 3. Isn't that what you mean?
Is that also the axis equation?
No, that's not the axis. This gives you the minimum point. We're saying h of negative 1 equals... The fact that negative 1, negative 3 is on the graph means h of negative 1 equals negative 3. Remember what this is like the x number, this is the y number. When x is negative 1, y is negative 3. Are you with me? You still confused, Andrea?
Always.
Okay. Now, we just spent, what, an hour going over this? It's not easy stuff. Now I'm going to maybe make it all easier for you. But you're going to get a question like 17, where I'm giving you the equation in this crazy, nutty-looking form. I'm going to ask you to give me the vertex as an ordered pair, okay? In this case, the vertex is negative 1, negative 3. I'm going to ask you, I'm not going to say draw the axis of symmetry. That's easy. You just draw a line right down the middle. I'm going to ask you to give me the equation of the axis of symmetry. And the equation is always going to be x equals the x-coordinate of the vertex. Let me repeat that. The equation of the axis of symmetry is going to be x equals the x-coordinate of the vertex. Okay? And finally, to find the maximum or minimum, I'll accept 3 different answers for the maximum or minimum. You can give me the number k, or you can write it as f of h equals k, or you can write it as f of x equals k. I don't care. The maximum value is actually the k number. Okay? Here k is negative 3. The minimum is negative 3. Now, I'm going to give you a quick shortcut method, which you probably will like better than my long drawn out method. But I've got to confuse you. I had a professor once at Berkeley. He says, a good instructor leaves his students confused because it gives them something to think about. So if I confuse you, it means I'm a good teacher. I'm giving you something to think about.
But it's too late game.
You learn from the wrong person. That's the problem.
All right. I'm going to give you another way of doing this kind of problem. I think it's actually